Let's go ahead and begin this week's webinar on what's new in SOLIDWORKS 2015. My name is Matt Morgan. I'm an application engineer at GoEngineer. I got a lot of cool stuff to show you, so let's jump right into it. Alright, so I'm going to start with a few ideas on some cool things that you can do with consumer design. So I'm going to take this model and just show you a few enhancements that you can take a look at here. The first thing we're going to do is just take a look in our favorites folder up here. We have a fillet that I want to just modify and show you a new option. Instead of having to use symmetric fillets where they're constant radius, you can now use asymmetric fillets, and we can change that to 10 by 5, and you can see the change that it creates. The fillets don't have to be constant radius anymore. They can be asymmetric, which gives it more of an elliptical, or you have the choice of conic row also for creating those two offsets from either 5 or 10. If we take a look at this fill surface, the fill surface has just been modified a little bit to show some of the things that we already have available to us in some of the other features of SOLIDWORKS. So down at the bottom we have some curvature display options, and the curvature display options lets us turn on the zebra stripes and the mesh preview, so you can kind of see the UV curves of your NURB surface, and curvature combs. Scale just comes in a little bit high, so let's drop this down to 1 so we can kind of get an idea of the curvature of this. You know, this comes in really handy in this case where we have two sketches controlling the curvature of how it fills this surface. You know, we have a tangent fill, but it's kind of forcing it to follow these sketches, so we can take a look at what effects that has on the curvature by visualizing these curvature combs and zebra stripes and kind of looking at the reflections. If you've never used zebra stripes, they're basically making your geometry like a polished mirror, and it's inside a striped environment. So what you're really seeing is what the striped environment reflects off of your part, so you can kind of see those black and white striped lines through there, and you can kind of get an idea of how the reflections will look, if they're sharp or curved or smooth, or if they're aesthetically pleasing, if you're trying to design something that's going to be polished or shiny and have a lot of reflections off of it. Okay. Another nice new functionality is the ability to show those curvature combs on any surface anytime. I can just pick on that geometry and, you know, increase or decrease the mesh density and take a look at those curvature combs on a surface too. It really helps you figure out where you have wrinkles, where you have tight curvature, where you might want to try a different approach to designing that, add another guide curve, try a boundary surface instead of a loft, or, you know, a few of those different things that you might learn in a surfacing class. So cool way to take a look at those and really analyze the curvature of your model as well. Let's take a look at the other side of this. So let's just rotate it around like this. And I'm using a 3D connection space mouse as well, a wireless space mouse, so if you see my movements are fluid and smooth, that's why. It's the 3D connection space mouse. So I'm going to isolate this bottom component here, and I guess it is this way, sorry about that. And we'll take a look at utilizing this sketch to cut with, and you'll see that it's an open contour sketch. There's nothing closing across right here. So if I use that for a cut extrude, new is that it does not have to go through all and completely section the model anymore. We can take advantage of the contours between the model and the sketch, so I can pick these faces and you know, cut them into or away from the model. So we'll drag them down that way, and we'll cut it into the model this way, and I don't really care what size. Maybe we'll go let's try 5 millimeters should be good actually. Okay, so we can pick those regions and utilize those instead of having to go through all with an open contour. So we can create that cut even though we haven't closed our sketch. Let's take a look at another option. If we go to a view that I have saved in here, let's say it's a screen cut view, and let's exit isolate so we can see our other component again. Let's say we're in this view and we want to make a plane that's related to my view orientation. So I can go to create a new plane and pick on this point, and I have an option to actually use the plane parallel to screen. So just by the view I'm at, I can create a new plane, and you can see that it updates, and I can update plane to where my current view is at any time and have it correct based on what my current view is. So if I wanted to create a plane in that screen cut view, I can simply update it in that view, hit OK. Now I have a plane that's created that was just parallel to my screen, so I can use that for a section view, or I can use it for cutting or sketching or anything. It's a full-on plane, so we have the ability to take advantage of that. Okay, so that's pretty cool. Let's take a look at a nice enhancement to the Photo View 360. It's kind of something that SOLIDWORKS used to be able to do, but Photo View 360 hasn't been able to do, and it's the render region option. So I can kind of render just an area to save some time instead of having to render the whole entire part. I can just, you know, drag a window around the area that I want to render, and then I could do the final render or the preview window, but the integrated preview is kind of nice because it just does it right here in the screen. It is warning me that I don't have perspective on. I'll turn that off. But the integrated preview gives you the rendered appearance while you're inside that. Well, I mean, it just shows it inside that box. So, you know, I can move the box around and it changes where it renders. I can move the model around, I should say. I mean, if I move the box too, it does the same thing. So I can really get a good idea of what the rendered view will look like without having to wait for the whole entire model to render. It's kind of nice to do work with photo view rendering. So let's turn that back on. Turn photo view off. I guess while I just did that, I might point out that sometimes it's pretty easy to drag your ribbon off of the toolbar and have it be floating in space again. A quick way to bring it back, just double click on it and it will go back to where it was before you drag it off. So if you've ever done that, it's kind of nice. It's nothing new, but it's a nice little trick. Let's go to our next topic, which is going to be the move face command. So let's switch to another file here. Don't need the volume turned up, so you end up hearing that in my presentation, but let's go to move face. Alright, so what we have here is a model that's all imported geometry. So we got this from an IGES, a STEP, a Parasolid, some other file type, and so we don't have any kind of features, but we still need to make some design changes here. We need to move this end so it goes beyond the bar here, and we want to have a little taper back to it so it's not sharp and you know, cutting people or anything like that if they bump into it. So we're going to use the move face command. So I'm going to activate move face, and then I'll just look straight down the end view here that I have saved, and I'll just window select all these faces. And as long as you're on the translate option, you have new options here in 2015. Instead of simply translating it blind like you have in the past, you have the option now to say, let's translate up to surface. So I have this plane right here that I can translate up to surface. I need to tell it where to go from. So actually the from entity will be this face, and then this one will be the to. So you're going from here to this plane, and so the from helps it figure out what direction to go and all that kind of stuff too. So you can kind of see the arrow changed. At first it was kind of pointing up normal to that plane. Okay, so there's my normal to, up to surface, and let's switch to offset from surface. Say we want it to be pulled back some amount from that surface, so I can say go 10 millimeters offset from that, and pull that back real nice. Okay. Now another option, like in this case, we'll say we have this piece right here that goes right up to this body, but this one doesn't. I believe that's what this first move face is creating that one. So now we'll go to move face again, and this time I'm going to change the end condition to up to body. So you have a lot of different end condition choices, very similar to extrude, while you're in the move face. So I can move it up to surface, or up to body I mean, and not have to worry about trying to extrude up to it or create sketches or anything like that. I can just take advantage of the geometry that's already there and use it. And just like in the past, I can always activate move face and make major modifications too, where I just window select all of these faces all at the same time and just translate them all at once. You know, that's something that's not new. That kind of ability has been around for a while. So it kind of gives us some push-pull, almost direct editing type of movements, but it's still parametric. We still have features and we still have dimensions that we can always edit and modify later. Okay, so it's pretty handy. So move face, a lot of cool stuff there. I think those will, I've already used them several times. They come in pretty handy, so I'm excited about those. So let's take a look at another option here. Let's look at some new enhancements to patterning. So let's start with this linear rail. Okay, you guys may have done this before, putting on some holes in here that need to be evenly spaced, and you know, you go make a modification to the length of this and your pattern fails because now it can't fit all 20 or however many holes are in there. So what we can do is edit the pattern, and we have some new options now to go up to something. So I can say I need to pattern this every 60 millimeters, you know, 60 millimeters here, up to this vertex. So it'll just say, well, if I go 60 millimeters, how many does it fit until it hits that vertex? And then I even have the option to step it back a little bit, and I can even use equations to say just match the distance off of this first one. So I can just say equal to that other dimension, and now it'll still have that spacing at least. So now it will, you can see that when one finally pops in, it has to be greater than that spacing from the other side. So we can say we don't want a hole if it gets too close and now becomes too thin and not strong, so we want it to always keep at least that you know, whatever it is, half an inch or inch of gap between there. So that's pretty nice. And you can also change that up to reference approach to be a little bit different, where I can say instead of being just spaced a certain amount, I can say just fit a certain number in there. So I can say I need 8 of them inside this distance here. And now you can see the difference where it maintains 8 and maintains the correct spacing, also with that dimension off of the end, same as this end. So it always maintains that and just evenly spaces it. Okay, really handy if you've had to do that a lot in the past. You have to use equations, and it has to update and rebuild every time. And having it be just part of the pattern is really pretty nice. Let's see, next example we have. Let's look at this saw blade. You know, this is another problem I've run into in the past. I have this saw blade, and I go into it and say, you know, this is actually a different material type, so I should really make it a separate body. So I go into the carbide tooth, so I can define it as a separate body. I need to unmerge the result so it doesn't combine it. And now the circular pattern fails because the feature that it was patterning is now gone. Now it's a body. So now in 2015 you have the ability to switch your pattern to bodies instead of having to delete your pattern and recreate it. If you ever had to do that, deleting your pattern can often have to delete child features, and you're recreating some geometry. You're recreating features that had to be deleted because the pattern was deleted. that can happen sometimes. So being able to just switch the pattern to a body and not lose the pattern will make it a lot easier in editing and design changes and not have to recreate geometry that got deleted because of a parent being deleted. Okay. Now, another great example of the SOLIDWORKS innovation and functionality that they add with each release is this colander. Okay, you can see this pattern here. You would have to create it with at least 2 separate features in the past and then pattern them individually. Well, in 2015 you can do that all in one pattern that's called a variable pattern. So if I just kind of look straight down onto this part and create a variable pattern, the variable pattern allows me to pick the feature, so I'll pick that slot, and then we can create a pattern table, and it just shows me a table. I can say let's add an instance to it, let's pick some dimensions. So let me try to remember what dimensions I need to pick here. Now we got the angle, and then we'll do the length of it and the spacing from the origin. Okay, so in this first one we're going to say it is 18 degrees, or you could say 360 divided by 20, or however many. You can still put that kind of equation into it, and we'll say we're going to make it 25 long and also 25 millimeters from the origin. Okay, so we'll update the preview, give you an idea what that did. It created a smaller slot 18 degrees over and moved away from the origin farther. Okay, so now I can say let's add another 19. Got a whole table here, so I can kind of take advantage of Excel-like functionality where I can drag this and it will automatically increment it in that case. This one's not really incremented, so I have to just paste this a few times in here. So basically it goes 40, 25, 40, 25. And did I miss one of those? Because I thought the 25 was supposed to be where it ended. Well, I might have too many spaced in there, but that's all right. So we'll paste all these in here, update the preview, and there we have all of our different sizes here. Probably didn't need the last one. Looks like it skipped it automatically for me, so I could probably just delete that row. Say OK, call it good. So now I have this variable pattern, and you can see I have each instance here. I can still pick on them and change each of their dimensions, which will update that table. If I wanted to go back and edit the table, I could do that, but I could still say, you know, this one, let's say there's something in the way here, or some different hole or something like that. I want to shrink it down and move it. Sorry, not the angle. Let's pull that out of the way and move it. I don't know. We'll just say that one's 30 as well. So you can see how you can still go pick on each individual instance, and if I update that, it should move back out a little bit further. You know, maybe I got something here. Maybe that's where my injection location be. Obviously, that's not where it's going to be, but you know, whatever the reason is, you can move that around. It's pretty handy. If I just take a look at a few other examples to really give you an idea of what that tool is capable of, it's pretty amazing what you can do with it. Here's an example that they use a spline, and that spline has several dimensions to it. So you can see that it is a style spline, and they've dimensioned the points that drive it, so these construction line points. and in the variable pattern they select all of those dimensions so they can change the curvature of it by moving those dimensions around, change the spacing of it. If you look at the variable pattern of it, it's pretty crazy, all the different dimensions that are changing, the spacing, the control points for all of those different splines. But you can see, instead of having to redraw that over and over again, you can very easily manipulate each of those and have them blend into each other a lot better. Okay, that's pretty cool. They also go kind of crazy with it and say, what if we're doing football specs, you know? Every single one of these was created from one variable pattern, I believe. Yep. So we have one object, and we're able to change the rotation and the position of them in all the different locations and create all these different instances of it without having to draw it and rotate it and all those kinds of things. You can just use the points and the dimensions, so you can see the dimensions used, or the position, you know, XY coordinates of it, and the angle of rotation for each of those. So it's kind of a cool tool. You have a lot of capabilities. It kind of opens the door to all kinds of functionality if you want. Let's take a look at one more pattern option, and that is with a fill pattern. Now it will include the instance count. So in the past it just filled the area with however many features would fit, but it didn't really count them for you. Now it does. So if I edit the pattern feature, there is an option to validate count to make sure that it is correct. So it says there's 302. If I go into one instance and I hit delete on it, it lets me delete that instance. That's kind of another way to use instances to skip if you wanted. You can delete them here without having to edit the feature. It's kind of nice. But now you'll see that that fill pattern count has updated to 301. And if you think about it, the time that you'd use this the most is going to be on your drawing. So if I say open drawing of this part, you're going to have to drill those holes out over and over again unless you made some kind of elaborate die that could punch it. But I'm assuming that you're probably going to cut it on a burn table or drill them out. So having the number can be useful. So I can say there's these 3mm holes, and I'm going to just place in front of it a note that includes the number. So I can pick that dimension, put the X by it. Oops, let's put it between them. I'll get it. There we go. So I'll put it between them. So now it tells me how many times I have to drill that to make sure I get the correct count. If I was going to drill it and then had to count, make sure I got them all. So I could put that on and make sure that they're all detailed correctly. And then I could hide this dimension or put it on a layer that's hidden or whatever. You have a lot of choices on how to remove dimensions. Okay? So that's kind of nice. All right. Let's take a look at, let's see, the next topic group. Let's take a look at, oh, I almost skipped one. This one's really cool. Pattern option for chain component patterns. So just a quick idea of what that's like. Something like this. And if you've ever tried to do that in the past, whenever you curve around corners, the mates of tangent and coincident could flip. It could go either way. So sometimes SOLIDWORKS will flip those around and you'll end up with 20 chain links all squished down into what looks like 3 because there's a whole bunch of them on top of each other. Well, now they've added this component pattern option, and so let's take a look at how that works. So if I look at, oh, that's what I'm going to show you. So gantry, is that the one I want? There we go. So in this you can see a couple of chains, energy chains, and as I move this around you can see that this one updates dynamically because that one can just follow a sketch. This one behaves a little bit differently because this sketch right here is designed in the context of the assembly. So this one can't update live, but you can see as I move it and then rebuild, it will readjust that sketch because that sketch maintains its relation of whatever distance off of this yellow part. So as that moves around, as soon as it rebuilds, it updates the sketch, and then it can correct the path for these chain components. Okay, So let's open up this part and take a look at it. So Control Tab over to it. So here we have that part. We have this sketch in here that can move back and forth, and that's really what's kind of driving the behavior of that chain. So what I'm going to do is temporarily fix that so I can connect these onto it, and then I'll show you how it works once we start moving that sketch again, which would change the path that these chain components are on. So let's jump into our pattern types, and you'll see that there's this new chain component pattern type. So if I pick chain component pattern, I can say let's pick the path would be either, I can either pick it manually or use the selection manager and kind of help pick it all at once, either by selecting the propagate or by switching it to one of your loop options instead of propagating tangent. So I'll hit OK to that, and that selects that whole sketch now as the path. And you can either pick the number of instances or just say evenly fill this whole path with that object. So now I'm going to pick the object that I want to pattern, and then I need to pick a reference that will snap onto it. So that becomes the snap, and then I need to pick a path alignment plane. So what's going to be aligned to that plane? So the front plane right here is visible. I'll just show that for a second, and then I'll hide the planes again. But you can see that that's where it will go. It's going to fill the path with the spacing. So we can adjust that spacing if you want. So now it's placed on that path, and I can still move it around on the path. So, oh, I thought I fixed my sketch. Let's pull this back over here and fix it. I guess I did not do that, even though I said I was going to. There we go. So now it moves on there. Okay. The fill path was one directional. Once you say OK, it doesn't add more when you move it around. It's not going to dynamically change your chain, which obviously you wouldn't want to happen. But as you edit it, it would go back and refill it, to the whatever fits the path. Okay. We have three other choices up here. Or two others. I have the distance one right now. We can switch to distance linkage, which now adds another selection because now it needs to link to it. Actually, I have this rotated too far, so let me switch that back. So it snaps this way, not the other way. Okay, so now that I switch to that, I can say, okay, the other side of the chain link is here, and now I say, okay, now it lines it up with the path on both ends of the chain, and then I guess it's not the way it's filling the path, it's not going to let me move that. So let's switch to the last one, and this is going to be the link option. So now what it's doing is automatically mating each component, and I can say how many. So let's say there's 19 links. So now it's just going to say basically this selection here and this selection here are what's mated in each following link. So the next link, this side, is going to be mated to this side of this component. Let me just see if I can open this one and show you. There we go. So that's how it behaves. So as that sketch moves around and it changes the path, you can see they continue to follow it dynamically. Pretty cool. So in this top level assembly, that is a sub-assembly that's set to flexible. So it will solve that same mate where it's following the path alignment of that sketch, which is mated onto these yellow components in the space component. Okay? Pretty cool. Alright, let's take a look at some surfacing functionality. Okay. The first thing that I want to talk about is the spline here. We have a standard spline. In 2014, SOLIDWORKS introduced a style spline, which is great curvature types of geometry. If you look at the style spline, I can create some pretty swoopy, complicated shapes. But if I look at the curvature combs, It looks very nice. You can see the curvature transitions are very smooth. There's not bumps and flat spots and things like that. It's a very smooth transition. Well, in 2015 they added the ability to convert a spline to a style spline. So I can say just convert this to a 4-degree style spline. So now this is a style spline instead of the 3-point spline. So you have really nice curvature, really nice transitions between those shapes. Okay. Now another cool thing is the ability to take this sketch and split it. Okay. You might look at this and say, well, SOLIDWORKS has always had split. But the thing that's cool about this is that it is a surface. It is not a solid body. So we can split surfaces now and make this now 4 separate surface bodies where that sketch crossed it. Okay. So I'm going to isolate this and just talk about the spline a little bit. Spline on surface has been enhanced a little bit to where it crosses the boundaries of other faces a lot easier. So I can cross the boundary of these faces, kind of create 2 separate splines here. Oh, sorry, that one wasn't on surface, so let's go back to spline on surface. Okay, so I can kind of manipulate that to whatever I want to create the kind of the shape of the material here, and then we'll trim it. Okay, and then we'll take a look at a new functionality in 2015. You do have to have SOLIDWORKS Premium for this function, so you'll hit flatten surface. I can pick on these surfaces, and I can select where I want it to kind of unfold from, so I'll just pick this vertex. You can see a preview of it, and it's able to take that complex shape and flatten it out. So as you're editing it, you can kind of see the mesh that it creates as it unfolds it. You can adjust the accuracy however you need. And you can look at, I forget where it's at, but there is a way to look at the where it's stretched, where it compressed. Maybe it was in the feature. I'm not seeing it. I know there's a way to analyze it. I'm sure I'm just not seeing it in the tree here somewhere, but there is a way to visualize. There we go. You got to right click on in the graphics area for it. There we go. So if you look at the deformation plot, it shows you where it stretched, where it compressed, to be able to unfold that. Okay? So that's kind of a cool new feature in 2015 SOLIDWORKS Premium. All right. Got one last thing two last things to cover. So we're going to cover sheet metal, and then I'll show you a few new things in routing. Let's start with routing. So I'm going to jump into a new assembly here, and just show you real quickly some new capabilities with routing. So it's an add-in that you'd have to turn on, routing. You notice that they changed the name of this to, it used to be called Office Products. They really don't call it Office anymore, so they switched it to just say SOLIDWORKS add-ins now. So if you're looking for Office Products, just look for the SOLIDWORKS add-in name instead. You can turn routing on. So what I can do is start a route here, and what we're really looking at is a rectangular profile for HVAC. So now we support rectangular profiled parts too. So I could drag this part out and put a T on it drop that on here, give it the same size, and let's see, let's pull this down a little bit. Maybe we have to jog around a column or something like that, so we're gonna kind of make an S-curve over here. Snap this right onto the other one. Looks good. Then we're going to come up here. Jog over like this. I'll just snap this one right onto that connection point. It's not the right size yet, but we'll reduce that down later. So we're going to pull a cross on here. So what you can really see is it's very much like piping, but now it's rectangular geometry. So I think that is the size we want, so that looks good. Pull these out here. We'll create their elbows that come over this way. And by the way, as I'm drawing that, I'm using the tab key to switch the direction that I'm drawing in, so I can go X, Y, or Z, but it always wants to be in two of those directions first. It all draws in the same plane, so tab switches the plane that it draws in. So I'll snap those on, and then we need to put some reducers on to reduce it down to the right size. This one you can see is bigger, reducing down. This one's smaller, reducing down, but again, just like routing, I can simply drop this on. It recognizes what size the connection points from here to here are and reduces to the correct size automatically for me. Okay, so pretty easy. Does a great job at that, and I believe I have a drawing of this one as well that I can open. So let me just open that real quick. So we have the length created, all that kind of stuff. Right now my HVAC component doesn't have the right component type on it, but you can just change that property in the file to ducting or something like that, whatever you want to call it. But just like routing, I have all the same kind of functionality. I can pull this into the model, do the auto balloon, all that kind of stuff to really simplify the process of creating drawings of ductwork. Okay, now I won't show you the other option. I'll just show you what we have available, and that is cable trays. So a cable tray is almost exactly the same as an HVAC. It's just got an open top instead of a closed rectangular shape. So it's kind of that cable tray. So I won't bore you with another example, but it's really the same kind of thing as this, just with an open top. Okay, so that's kind of nice if you use routing, or even if you don't use routing yet, but you create some HVAC designs, and you need to be able to visualize where it goes, how it fits in your plant or facility or whatever. You can create that geometry in SOLIDWORKS routing now. Alright, let's take a look at sheet metal. Alright, with sheet metal you have a few new options as far as the lofted bends and things. So this is kind of your finished approach. If I go back to the start, you can really see what the advantage is here. In the past, our profiles for the start and end of a lofted sheet metal bend had to be parallel to each other. But now you can see these two planes are definitely not parallel to each other, and that's still okay for a lofted sheet metal bend. So if I go to lofted bend, I can still pick these components and still create my lofted bend with, you know, however many segments or tolerance or whatever method you want to use. And I can create that geometry even though the two profiles are not on parallel planes. So you can see I can still flatten that out and get the flat pattern of that shape. Okay, I'm going to switch back to the completed model. and take a look at a few new options here as well. The first option I'm going to show you is going to be in the options under sheet metal. So it's going to be a document property under sheet metal. And what you can see here, there's some new options to show the form tool profiles when flattened, and the form tool centers, and gusset profiles when flattened. So I'm going to show both of those. So that would be form tools or gussets. In 2014 we created these gussets. I think it was 14, it might have been 13, but maybe it was even older than that, I can't remember. But anyway, these gussets are real easy to just pick the two faces and place a gusset in, but then when you flatten it, they go away, and it's hard to tell where the gussets are and how to dimension them. So now in 2015, the profile shows up as well as the center, so you can use either one of those to help locate where the gusset is going to be punched, so you can dimension it and detail it on a drawing. So that comes in handy. That's pretty huge to me. Another nice enhancement in sheet metal is the ability to preview a sketched bend. So if I'm drawing a sketched bend, I can just say draw it through here. Just missed horizontal there. Draw it through there, and we'll say OK to that because I started it with the sketch bend. So now it goes to the sketch bend, and I can say what face is going to be fixed. And now I get a preview of it. So I can say, okay, I need to go 60 degrees, and I need to reverse the direction. So I get a nice preview of it by when I do a sketch bend. Instead of having to just say okay, see where it goes, and then edit it again, now I get to see it. So that's another one that's like, SOLIDWORKS really does a good job at preview and everything, but that was one that we didn't have any way to see what it was going to look like before. So having that will be pretty handy when you're working with sketch bends. So that's nice. One more thing on this sheet metal, and then I'll open up for questions if you have any. If you mirror a sheet metal part, so let's pre-select a plane, let's say mirror off the right plane, and we'll go to mirror part. A new option in 2014 is to include sheet metal information. So when I hit OK to this, it's going to create the mirrored part. I guess I could have even turned on model dimensions so they would come in, so when I make a drawing of it. But really the cool part is the sheet metal information. So the mirror has the ability to do the flat pattern already, and I don't have to insert bends and try to figure that out. And it can also take the sheet metal information for the cut list from the parent. So when I look at the sheet metal properties of this, they're already filled out with the cut around the perimeter, cut around internal components, the thickness, the material, all the stuff that we get with sheet metal now propagates into the mirrored part, and you don't have to recreate all that stuff. It automatically brings that in from the parent. So all this information that's very useful now just propagates over. The flat pattern's already here, so I can just flatten it right away. I could go right to making a drawing of this without having to add anything or make any changes to it. So I guess I don't have a drawing with it already done, so I could just say make a drawing from it. Sure, I don't care what it's called. But now it's going to create a flat pattern view automatically, just like it does with normal sheet metal files. So I can say bring in that flat pattern, and it automatically has all the bend information, which obviously I need to be on a bigger sheet of paper so they're not so tiny. So let's say maybe a D-size piece of paper would be better. And then my scale could get bigger. Let's see if quarter will fit. No, it's a little too big. There we go. But you get the idea that really having all this bend information already there, not having to insert bends, not having to recreate it, anything like that really saves you some time when you're working with sheet metal design. So that's all I have for you. Again, this has been Matt Morgan with GoEngineer. I'm an application engineer here. If you have any questions, feel free to ask them now. You're also welcome to email me at mmorgan@goengineer.com, and I'd be happy to answer any questions as well. So if you want to ask a question, just go ahead and post it on the GoToMeeting question, and I'll try to read them out loud and answer them if you have any. If not, then thanks for attending, and appreciate spending time with you.